Today we're going to be talking about arcs, chords, and angles. A central angle is an angle whose vertex is in the center of a circle. So for instance, angle DCE would be a central angle because the vertex is in the center of this circle. A minor arc is the smallest arc between 2 points. So for instance, let's say we choose points D and E. This right here, this arc DE, is what we would call a minor arc. A major arc is the largest arc between the 2 points. So this arc right here that goes so far around is the major arc of DE. A semicircle is half the circle. The starting and stopping points are the endpoints of a diameter. Now, the way that we write how to find the measures of arcs. If we wanted, say for instance in this picture, to find the measure of minor arc DE, we would write that as the measure, and we would put the symbol for arc, which is actually a little arc. Let me rewrite that so it looks a little bit better here. Measure of DE with an arc on it, arc over the top of it. And the measure of a minor arc DE is equal to the measure of its central angle, DCE. So the measure of minor arc DE is equal to the measure of that central angle, DCE. Now, a major arc, how do we write that? The major arc that goes from D to E, we would write as the measure of D. Now pick another point on the circle between D and E in the major arc. So I mean, you can say A if you want, you could say B. So the measure of major arc DAE would be equal to 360 degrees minus the measure of that central angle DCE. And that makes sense. You're taking out this one section of the minor arc to find the measure of the major arc. And of course, the number of degrees in a circle is 360 degrees. So let's move on. Let's say we are given this diagram, and we are asked to find, first of all, the measure of angle APB. Well, it looks like the measure of minor arc AB is 95 degrees, so that would be equal to the measure of the central angle APB. So that would be 95 degrees. We can even write that right in. Now, the measure of angle BPC, right here. Well, let's look at what else we know here first. First of all, we know that the measure of minor arc AE is 50 degrees, so we also know that the measure of the central angle APE is also 50. We know that this is a semicircle here going from point E to C, and we also know that we're creating a straight line here. So these three angles that I'm pointing to, EPA and APB and BPC, would all add up to 180. So if I could find the measure of 50 and 95, if I added those together and subtracted it from 180 degrees, I would have the measure of that central angle BPC. So let's do that. So we're going to say 50 plus 95 gives me 145 degrees. 180 degrees minus 145 gives me 35 degrees. So we know that the measure of central angle BPC would be 35 degrees. Now, we want to find the measure of arc DE. Well, the measure of arc DE, it's a minor arc, it's going to be the same as the measure of its central angle DPE. Well, let's look at this. Here we have a straight line that's being formed by this angle of 50 degrees and DPE. So the straight line, of course, has a measure of 180. So if I take 180 minus 50 degrees, that gives me 130 degrees, which must be the measure of this angle, DPE. Well, the minor arc has the same measure as the central angle, so minor arc DE measures 130 degrees. Now, if we look at arc AED, notice that AED, the angle, or I'm sorry, AED, I'm sorry, it corresponds with a straight line, I should say, as its angle. Well, that measures 180 degrees, so arc AED also measures 180 degrees. Now we want to look at minor arc CD, which corresponds to central angle CPD. Well, CPD and APE are vertical angles, so they're congruent. So that means CPD has to measure 50 degrees, and that corresponds to the minor arc of CD, which must also measure 50 degrees. Lastly, we want to find the measure of major arc BEC. Well, we know it's 360 degrees all the way around the circle. And if we just take out this 35 degrees right here, because that's the only part that's not being included, we take 360 minus 35. That gives us 325 degrees, which gives us the measure of major arc BEC. Let's move on. Here are some facts that will be quite useful to you. If two chords are congruent, then their arcs are congruent. So let's say that I have these two chords that I've created in this circle. Let's say they're congruent, and let's label these points. We'll call it A, B, C, D. If those are congruent, then we know that the measure of minor arc AB is equal to the measure of minor arc DC. Now, if a diameter is perpendicular to a chord, so here's your diameter, here's a chord, then it bisects the chord and the arc. So if these are perpendicular, I'm going to just label these points. If AB is perpendicular to DE, we know that the chord is bisected, so we know that AC and CB are congruent. And we also know that the arc is bisected, so we know that the measure of minor arc AD would have to be equal to the measure of minor arc DB. Our last fact for today, chords are congruent if they are the same distance from the center of the circle. So here's the center, which I'll mark a little darker so you can see it. And if we know that these two segments here are congruent, then we know that the chords are congruent. So let's label these points A, B, C, D, E, F we'll call the center of the circle G. Okay, so um, if we know that G, F, and GE are congruent, we also know that those chords AB and CD are congruent. Up here I should have also put the lines above the congruency statement. All right, so that's it for today. I know it's a lot of information to absorb. Please write down your questions, bring them to class, and so we can discuss this and we can clear up any questions you have as soon as you come into class. Thank you very much for joining me.